Dear participants of conference, our presentation is about intellectual biotechnical systems in livestock and its theoretical aspects. There is a class of man-machine systems which is transformed into the system man-machine plant or man-machine animal in agriculture. As you can see, in agricultural production, biotechnical systems have the properties of bimodality. Then there are two or more biological objects, as a person as a managing operator and a service object, plants or animals. In addition, the uniting environment of this biological object is also a biological object, the field, so as the main source of energy for plants and animals. The process of energy conversion is considered in agricultural production in the classical works of academician Garatkin, where he considers three components of this process: an energy source, sun and atmosphere, energy storage, soil as accumulator, and energy receiver, plants and animals. These works were invaluable for the progress of the theory and practice of creating new technology for agricultural production, converting its designing to scientific basis. The increasing complexity of machine technologies led to the formation and development of scientific methods of substantiating and calculating them. Not only individual working elements were analyzed, but also aggregates at large, which affected the quality of service and the state of biological objects ecology. Also, a cluster of man-machine systems was formed. In animal husbandry for biological systems is used term BTS. This term is used in Professor Kartashev's works when he was studying the process of interaction of milking equipment mechanisms with the cow's udder. There are known works of fractional system in the field of medicine performed by Professor Anokhin. By Professor Ahutin was suggested the term biotechnical system, BTS, to distinguish a special class of large systems, which are a combination of biological and technical elements interconnected in a single control loop. Currently, under the leadership of academician of the Russian Academy of Sciences, Chernoivanov, research is being carried out in this direction, and a new concept of biomesh system has been introduced, which in agricultural production more accurately reflects the interaction of machines and units with biological objects. The term equipment is often used in animal husbandry. The traditional self-moving machines include feed preparation and dispensing units. Therefore, both terms BTS and biomass systems are obviously applicable here. With the development of automation and informatization of production, the role and importance of systematization of knowledge and management of complex biotechnical and machine complexes increases, especially in such an important industry as animal husbandry. To improve the efficiency of complex biomachine and technical systems, it is necessary to develop the system research in order to further intellectualize and digitalize agricultural production. In modern milking parlors, operator's work is quite significant. He has to make frequent movements to service animals, rub off the dark, milk the first streams, connect milking machines for a long time, and the shift is about 8-10 hours. All these operations cause physical fatigue and information overload. Such identical, monotonous operation will be performed by robots in the future, it's undoubtedly. The only question is the high cost today of robotic technologies. In this regard, an analysis of ergonomics of the work of milking machine operators involved in high-performance milking stations, and it deserves attention. The higher the labor productivity, the higher the flow rhythm and the frequency of movement performed by operator. There are two approaches to the study of human-machine systems. There are anthropocentric and machine-centric. The first assumes and assigns a decisive role to the person, the second to the machine. Of course, the role of man in system man-machine-animal is not only preserved but also increases. However, with the development of automation tools, the functions of the human operator, HO, will gradually be replaced by a human expert, human HE, and a human user, HU. The general functionality of the human subsystem can be represented as the sum of functionals. Whereas you can see function of human operator tends to a minimum in automatic system, while the role of accumulating human knowledge in models and algorithms increases, and they transfer to the function of human expert and human user. Therefore, at the first stage, the manual control functions will be transferred to the machine, and the intelligent functions of the operator will gradually be transferred to the machine automaton, while the person will still remain in control and correction of machine algorithms, animal behavior models, and etc. The functionality of the machine will increase. In this context, the role of machine factor in modern agricultural technologies will increase. For a person will be mainly assigned the function of human user and human expert. Based on the weak neural network artificial intelligence, the machine will gradually learn the relatively simple function of adaptation to biological options, the quantity of and quality of feed consumed, the measurement of milk yield, and the completeness of milking, disease control and treatment. At the first stage of production intellectualization, the information component will increase, and illustrating the interaction of the machine-animal subsystem. And the machine will use its sensors to observe and signal problems in the subsystem machine-animal. What went wrong? For example, diseased milk yield, acidosis of the rumen of the cow's stomachs, and etc. The signals will be transmitted through the corresponding base stations to the automated workstations of the specialist, as you can see on the picture, to the human expert and to a specialist, veterinarian, zootechnician, and other operator, who will study them, compare them, and transmit commands through feedback to local biotechnical and biomachine systems to the local BTS or BMS. Redirect and increase the levels of their adaptation. At the same time, the operation of individual local BTS may not require communication with the control center, human expert or human user, through the corresponding AVP to make a decision and directly transmit signals from one LBTS to another, using autonomous multi-agent control modes. For example, the local BTS of feeding receive a signal from milking BTS about the change condition of functioning, for example, decreased milk yields in a group of lactating animals without changing their health indicators. The local BTS of feeding system makes a decision to adjust the feeding rations by sending duplicate signal to the technician. In this case, only the local control loop can work without entering the database and the AVP. And it's enough to adjust the ration automatically. The knowledge of specialist is not required. they can only send SMS messages in the form of, for example, in the forms. Other local BTS can work similar. For example, the parameters of the microclimate change, the gas content of the room increases when the manual removal system is working, the forced ventilation turns on, which removes excess harmful gases. In case when intervention of specialists is required and the local level of interaction cannot control the situation, information signals pass to the automated workplaces, and the specialists make a decision, examine animals in separated groups allocated by the subsystem. A block of parameters informed in each local subsystem, deviation of the current parameters of biological and machine objects are measured and compared with the test characteristics and the limit values. Because of complexity and diversity of the monitored indicators, this grouping will make it possible to study them separately. The indicators of the first group can include lactation indicators, for example, milk yield rate, milking duration. The indicator of animal health can include the number of somatic cells in milk or abnormalities in growth of reproductive organs. The second group of indicators characterizing the work of human operator may include the following indicators. For example, duration of manual operation for servicing an animal. The group of indicators characterizing the machine factor includes the duration of the services cycle of animals, the consumption characteristics of the distributed received materials, feed, manure, milk. Thus, at the present stage of development of BTS and animal husbandry, a three-link system is being transformed into a two-link system with the polarization of some systems, human expert and human users, and subsystems, machine-animal. There is a polarization of the subsystem machine-animal into a local machine-centered model of LBTS, which can function with a high degree of autonomy, while the powers of the human operator are delegated to the machine. The zone of influence of the anthropocentric factor decreases, but at the same time, the level of the intellectualization increases, since a number of manual operations performed earlier by the human operator are handed to the machine. The level of intellectualization should not be mistaken for the level of automation, since the latter places only simple mechanical operation with manual control. And the level of intellectualization included the level of automation plus additional visual and analytical functions of the human operator, which he always used for evaluating the interaction of the subsystem machine-animal. In the automated system, human operator, machine-animal, the human operator works by directly interacting with the machine and the animal, performing known functions and manual operations. In a robotic system, some of the manual and simple intellectual functions of human operator are performed by machine, and human expert or human user are having functions of increased analytical content, high intelligence, or prediction. The number of intelligent and visual and analytical operations transmitted to the machine by a human operator is constantly growing. Therefore, functionality that generalizes that function is also growing rapidly. A human operator cannot grasp the immensity, keep track of everything, especially on a large farm. So his tasks as a human expert or human user is to analyze reports sent from the LBTS or individual RAM signals from animals, and to intervene the process in threatening emergency situations related to emergencies of the machine or animal diseases. It is necessary to study separately whole groups of indicators related to the components of a complex biomesh system, which is a modern dairy farm. Thus, a modern automated or partially robotic dairy farm is a complex multi-level biomesh system, including partially or completely autonomous local biotechnical subsystems that perform specific technological processes, subsystems for receiving and transmitting signals of animals, machines, and information and analytical center, which includes automated workplaces of shift specialists who make management decisions on certain situations. The progress of biomesh systems in animal husbandry is based on the expanding machine-centric model of the subsystem machine-animal, which takes in more and more intellectual functions passed on by a human. The latter reserves control, coordination, and management of entire system. There is a lot of computer control systems in animal husbandry nowadays, for example, feeding systems, water treatment, and some steps of milking system. Further work is targeted on minimizing of human factor for milking operations such as dark treatment or connecting of milking machines. One of the options is to use laser scanning for dark with robotic manipulator to replace manual operation. Thank you for your attention, and you can see on the slide the contact information of the authors of this presentation.